All right, Algebra 2. We're going to start with lesson A, and that's found on page number 3 in your textbook. And we're going to start with a couple of really reminder type of things in geometry. And so we're going to go back to the old what is a line kind of thing and add a couple points on here. And we're going to designate these as a couple of different spots, but we're going to learn a couple things, all right? Line. What is a line? Well, a line, if we choose from a line from A to B, will be notated like this. AB, and then there's going to be an arrow on both ends to designate line AB, okay? Segment, if we use AB, looks like this, with an arrow on top, or with a line on top of it. Array is AB, and then there is one arrowhead on it. So on page 3, you're going to see how to designate those, how to write them, how to deliver them as far as a connotation is concerned, and it's pretty simple stuff. As we move on, you can turn to page 4 and a couple of other things to demonstrate here. Okay, and we're going to start with what they call a plane. What is a plane? Well, plane is basically anything that you can create that you can put a point in. So we can have point A, we can have point B, we can have point C. You can do this infinity and find all of those things. But dealing with a plane is pretty simple. Now, not only dealing with a plane, but we're also looking at what does an intersecting line mean? Okay. Well, a line, of course, has arrowheads. And we can intersect that at any moment, and whatever the middle is, wherever that intersection happens, is designated as the intersection, okay? So not difficult. However, when we actually get into some of the geometry parts of this, some of that will get a little bit tricky as we go on. But we're going to start with a straight angle. How do we measure angles? Okay, so when we measure angles, we actually measure them based on the initial, where we start, initial, to the terminus or terminal. This would be a 180-degree angle, okay, or a straight angle. If we want to show a right triangle, that's a 90-degree angle. And it doesn't go past that. It is an actual, and it's indicated very well by this little box. If that little box is there, it's kind of showing that it is a square, or it is a right angle. An acute angle is demonstrated, it is less than 90 degrees. 90 degrees exactly is a straight angle. This would be acute. Okay, it's less than 90 degrees. And obtuse would be greater than 90 degrees. Okay, and so let's call this one right here 135 degrees, which is obtuse. It's greater than the 90. Okay, 90 would give this look and have a square, but that's not what we have. And then one more angle that we see that maybe we don't use very often or talk about very often. But this angle right here on the outside is called a reflexive angle. All right, so pretty easy to understand, to notate, to signify. And again, we're going to be challenged with using this in a greater detail in Algebra 2, not just writing these out. So let's go to the next page. Let's go to page 5 and talk about a couple things. All right. First of all, there is I use the word initial and terminal. And the terminal side of things and the initial side of things, they can be flip-flopped. But in geometry, because we often use a coordinate, okay, which we start with quadrant 1, quadrant 2, quadrant 3, quadrant 4, we kind of go in a counterclockwise fashion when we deal with this. So same thing. So if we're starting here, and let's say that this is our quadrants, okay, in dotted lines, all right? We're in quadrant number 1, okay? And we're going to start with the initial and go to the terminal, all right? And there's nothing exciting about that. It's just what it is, okay? So let's call that 50 degrees. And if we were to do another one, except we're going to go past the initial, we're going to go all the way 360 degrees, and you know what? We're going to go here. Because we've gone 360 degrees, and we know that the initial was 50, that means 360 degrees plus 50 degrees is going to leave us 410 degrees. Is that possible? And the answer is yes. And found in your textbook here, it's very, very possible. In fact, we're going to be doing a lot with that kind of look. All right. So, if you would, you can turn the page, and we're going to look at a couple of examples. First of all, we're going to look at A.1 in your textbooks on page 6. Okay. And basically, what we have here, is we have some angles. And we're going to be looking at and looking for a couple of these. They noted this as a 30-degree angle. Down here, this angle here is 40 degrees. And they ask us for something very unique, okay? And I'm going to show what they're asking for in green. We want to know what x degrees is. And we also want to know what y, but watch this, we want to know what that is. This is y degrees, okay? So how in the world do we figure that out? Pretty easy. It doesn't take too much to think, but let's just start with this quadrant, and we're going to call this quadrant 1, okay? Quadrant number 1. We know that if we were to draw a right angle, we could do this here. And because this is 30 degrees, that means that this whole thing is 90 degrees. So 90 minus 30 degrees leaves us 60 degrees, which is what this angle right here is. Okay? So if we know that is 60, 60 plus 30 equals 90, pretty simple. Okay? Now, let's go down to y. Y is a straight, or a right angle plus some. So we have to do the same thing here in quadrant number 4 to figure this out. So if this is 40, what is 90 degrees minus 40? How do we figure that out? Well, if we do the math, we note that this is 50 degrees because 50 plus 40 equals 90. So if this is 50, that's great, which means that y is 90 plus 50. So 90 degrees plus 50 degrees is going to give us 140 degrees. So y degrees equals 140, x degrees equals 60. Not difficult at all. There's our answer. So, because you guys are so smart, and because all of this is really, really boring, we're going to move on, and we're going to look at a couple of other looks as far as this is concerned, okay? So, you're also going to see something like this. You're going to see, try not to do that, you're going to see a line that is here, and a line that is here. We're going to call this 50 degrees. We're going to say this is y, this is x, and this is p. Well, how in the world, with only one number or degrees, to find out the rest of this? Well, if you remember in your other math classes that this angle here is the same as this angle here. So we already know x. We also know that we can figure out a couple of really interesting things because this is a straight line. We can say that this and this equals 180 degrees. So if we have 50 degrees and we subtract 180, that means that we can come up with what y is. And you'll notice that because this is 50 degrees and this is 180, 180 minus 50 gives us 130 degrees. So that means that this quadrant, degrees y equals 130, which is exactly what p equals as well. So not too difficult to find the answers to these, because if you know one of the angles, and they are pretty simple to see, you'll be able to get them, okay? One more look. If we go to the bottom of the page there on A.3, you're going to see a different look, and we're going to use some algebra in this one to come up with the answer, because they kind of throw in a new or a different look at it, okay? So 5x degrees here, and you'll notice that is in parentheses. And then on this side, we have 2y degrees. They give us the actual 110 here, and then we are looking for p here. Okay. So how do we do this? Well, again, same thing. We know that the 180 degree rule still applies, okay, on any straight line, and that is a straight line. So that in green equals 180 degrees. We do have 110 demonstrated for this part of it, okay? So if we want to use this whole equation, we can run 2y and 110 equaling 180. So it looks like this: 2y plus 110 equals 180 degrees, because 2y total plus 110 does equal the 180. So how do we get, basically, how do we solve for y? Well, a couple ways to do that, okay? And first of all, what we want to do is we want to take and subtract 110 from both sides, okay? 110 degrees from both sides. That way, 2y equals 70 degrees. If we divide by 2, y is going to equal 35 degrees. And we have to show 2 times y, because we need to know what that is. So y equals 35. Don't answer that it's 70 degrees, because it's 2y is what we're looking for, which means we have to do the opposite, and we have to divide y by 2. And that's exactly what we did up here, okay? So again, those are pretty simple algebraic problems that we can use with our geometry, and similar for every other one that's involved here, okay? All right, now let's go to A.C. And essentially, A.C is going to talk about kind of numbers and what this looks like, okay? An absolute value, okay? If I have 3 as my number, 3 means 3 something, okay? 3 tick marks, 3 T's, 3 dogs, 3 cats, whatever. It's 3. We can actually get a number. And if we show this on a number line, if this is 0, we would go 1, 2, 3. It's 3 units, okay? 3 units from 0, and we note that that is the case, okay? So we can see that. So we also know that numbers have their opposites. So if we go to -3, you'll notice something interesting, that it's still 3 units from 0, but we put a negative in front of it. So how do you show an absolute value? Absolute value looks like this: a line with a negative number and another line, which tells us that the value of a -3 is 3 units still. It's 3 units because we went 1, 2, 3. Not difficult at all. All right, so absolute values are pretty simple, and I know you guys, most of you know them without a problem, and it's going to be easy to learn and go through. Okay, so let's step into a couple of examples. Okay, so I'm going to go to page 8, and 8.4 is going to have a little exercise for us, okay? And it looks like this. We've got a negative absolute value of -4 minus 2 plus an absolute value of -5. So what do we do with this? Let's break this down. First of all, what does this negative and this negative do? Well, in the middle here, we note that this value inside these marks is actually equal to a +4. But because we have an outside negative here, that means that this term right here is equal to a -4. We also see the sign here as a -2, and then we drop the plus sign and we have another value here. Because it's absolute, it has to be a 5. So what's a -4 plus a, oops, sorry, that should be -2, equal? Well, that's a -6 plus 5. Well, the total of that is going to be a -1. Pretty simple, but using absolute values here, remember, this becomes positive. This inside these brackets becomes positive, and if there is something on the outside, that will change the actual sign that we see on the problem. So again, these are reminders and pretty easy to look at and find, okay? All right, so now we're going to go to AD, and we're going to look at A.D, and we're going to look at properties and definitions. And as we look at a couple things through this, you noted that the communicative properties were as we discussed before, but there's a couple of things that notation-wise we need to clear up. So if we have a -3 squared, and the difference between that and a -3 squared is unique. Your math book will tell you that we use the thumb rule, okay, on this example, which means that we're essentially going to cover this up with our thumb fingernail, and we're going to say, well, what is 3 squared? Well, that's 9. And then what happens is we uncover that and we give it a designation of negative. Here, what we're saying is that this -3 is saying -3 times -3, which is going to be a +9. So they look the same because the values look the same. We have a negative here and a positive here. Now, as we look at the example, okay, there's an example that your textbook gives, and it's pretty easy to follow, but it'll help if we do this one time so that we can clear the air without having any other problems. So here we're going to have a -2, and I'm on 8.5 on page 9, okay? And that is cubed, minus 2 squared, and then we're going to say minus 2 squared, okay? Or this is a negative in here. Okay, so we're going to deal with this term first, okay? And we can break them into terms pretty easily, okay? So let's do what's in here. We don't use the thumb rule because it's already in parentheses. So what we're saying is -2 times -2 times -2, which is going to give us 3 negatives, -8. All right, next up, let's deal with this term. This is the term that we do use the thumb to cover up that. So 2 squared is literally 2 times 2, which is 4, and we're going to drop that negative. And the last one that we're going to work on is this term. So let's just think about this. We've got a negative 2 squared. So 2 negative squared, or -2 times a -2 equals a -4. Or a +4 rather, because there's 2 there, but we keep this negative here. So we're actually going to have another -4. So of course, -8, 4, and 4 gives us a total of negative 16. So that is our answer. A lot of people will mess up right here. Well, where they will say, oh, okay, that is a negative 2 times a negative 2. That's not what's happening. In order to do that, you have to see this kind of look, all right? And there's several problems that will give you that look in this first lesson. All right, if you need to go back and review any of these things that are on here, please feel free to replay the video, and your assignment is going to be problem set A, 1 through 30. All right?